Hello and welcome to another Northcoders graduation showcase, coming to you from a rather wet and stormy Friday afternoon here. Now, if that comment has provoked you to look outside the window and think, actually it doesn't seem so wet and stormy, where is this weather system David is describing? Well, I apologise, that is the current weather forecast for Friday afternoon, and this is actually a pre-recorded message. All our presentations today will be actually pre-recorded to ensure that there are no technical mishaps. However, the chat box to the right is very much live, so if you have any questions about our presentations, any comments you wish to share, any emojis you just need to get off your chest, please post them to the box to the right and our project teams will be happy to respond. Now, these project groups are actually a first in Northcoders history in terms that they have not set foot in either of our Northcoders campuses, in Leeds or Manchester. All teaching has been done remotely and these graduates have never met each other. I'll let you decide, graduates, whether that was a good thing or a bad thing after the past 10 days you have spent on these projects. Now, I am going to leave all introductions for the project groups themselves, so without further ado, let us start.
Hi, I'm Stephanie Thornley and I'm here with Richard Bacon, Zach Pinfold and Schwam Mack to tell you about our blooming good app, Budding. Our app can measure a plant's height and track its growth using a mobile phone and the measurement of the real-life pot height. I personally have a backlog of old plant photos in my phone, which I manually compare against each other to observe their growth. So this app was inspired by wanting an efficient and easier way to keep track of our plant's progress. While there are currently many apps that can identify a plant or remind you to water it, we had not yet come across one that could measure it and track its progress. This app is for anyone who wants to find out just how green-fingered they really are. So, let's get growing! When starting the app, you can either log in using an existing username or sign up. Because we have no plants yet, we will be prompted to add a new plant snapshot. As a new user, I don't yet know how to use this app, so I can select tutorial to be taken through each stage step by step. First up, how to take the picture. This details the perfect way to take a photo of your plant, which will get the most accurate measurement of the plant's height. Position the phone midway between the top of the plant and the bottom of the pot, and at about a 90-degree angle. The user should not take the photo too close. The plant and its pot should be positioned in the middle of the screen, as shown. We also provide some photos demonstrating what a good photo looks like and things to avoid. We then tell the user we need the real-life measurement of the plant's pot, from the base to the top of the rim. We need this measurement to be able to calculate the plant's height. We also inform the user that they are able to change the plant's pot height in future if they want to. Finally, in step 3, we guide the user through how to use the measuring screen. This shows a GIF which demonstrates parts of the photo which need to be aligned with the markers. The bottom of the pot, the top of the pot, and the highest point of the plant. We can then go straight to measuring a new plant. We have the option to take a photo or pick from gallery. Here I'll take a photo. I'm happy with this photo, so I'll select Use Photo. I then need to give it my pot height. The user only needs to input their pot's height once, as the app will store and use when the user adds more plant photos and measurements. And this takes us to the measuring function. Here, I place the first marker on the bottom of the pot and press Add First Marker. Then, I place the second marker right at the top of the front rim of the pot and press Add Second Marker. Lastly, the third marker at the top of the plant and press Add Third Plant. If I decided I wanted to redo the marker positioning, I could press Reset. I can now press Submit, which will take me to the form to enter information about my new plant. All fields are required, except watering frequency and soil, which are optional. Here, I will only add watering frequency from the optional inputs. Then, once I've added my new plant, and it has been successful, I will be taken back to my garden where I can see my new plant and its height.
Now we'll run you through the app from the perspective of someone who has previously signed up to Budding and show you how easy it is to view and edit the plants you have already stored. After logging in, you're going to land on your garden page. This displays all the plants that you've stored in your app already. You can sort through your garden by newest or oldest, how many snaps you've taken, or by plant type. We're going to check out the herbs today. Minty has been growing for a while now, so let's remind ourselves about how she's getting on. I can see its information displayed on the plant page, look at some recent snapshots in the carousel, and I'm going to head into the All Snapshots page to see the plant's growth over time. We can see it displayed clearly on the graph above, and we can check out all the images stored in the database from when it was started growing. My rosemary plant has started to grow a lot since I last took a photo, so I'm going to take a new snapshot so we can track its growth. After selecting new snapshots from the plant page, I'll be prompted to take a new photo. After confirming, we already know our plant's pot height from when we stored it before, so we'll move straight onto the measure page, which is set up exactly how I remember it from before. The plant's height will now be updated across the app. And I've decided to move this plant from the outside to the inside, so we're going to need to update its information. That's easy. I head back onto the plant page and select the edit button. Effective UI makes it easy to navigate to the correct form, where I simply switch the data from outdoor to indoor. If you decide to pass on your plant onto a new friend and no longer want to see it stored in your app, simply head into the plant's page and hit the delete button below. Thanks for watching. Now on to some more details about our tech stack.
Because we know how big the pot height is in centimetres, by measuring the height of the pot in pixels, we can calculate a scale of how many pixels are in a centimetre. We then use this pixel to centimetre scale to calculate the plant height using the pixels we obtain from placing markers at different points on the photo of the plant. When we place our markers, the screen detects the coordinates of the position of the marker. By storing the screen's y-axis coordinates from the bottom of the pot and the top of the pot, then calculating the difference between these pixels, we can use the pot height in centimetres to calculate how many pixels are in a centimetre. We then measure the pixels from the top of the pot to the top of the plant and calculate the real-life height in centimetres using this scale. If the photo has been taken correctly, the plant height is accurate to within a few millimetres.
We wanted our app to function properly across both Android and iOS, so we decided to build our app in React Native. We had used React for a previous web project, but as we discovered, React Native is a completely different framework to work with, and came with its own learning curve. We identified a lot of functionality within React Native that would be extremely useful for the functions within our app. For moving the elements around the screen and tracking the plant's height, we used PanResponder, an inbuilt React Native gesture controller, which allows us to use the screen coordinates to calculate the height of the plant. When building the tutorials, we were going to use GIFs for the animations, but we found the visuals to be grainy and not a good fit for the look of the app. React Animations is built into React Native and allows us to create smooth animations with SVG files and styled components. React Animations had a steep learning curve, but we managed to get it working on a looped animation to effectively illustrate the tutorial screens. For capturing the images, we used the React Native Image Picker. We then use Amazon's S3 buckets to store them. React Native charts were used as a clean way to display our plant's growth progress over time and integrated seamlessly into our app.
So we decided to use Expo's built-in tools, and with that we were able to visualize and test our application for functionality throughout the building process. It also helped us to understand exactly how the app would perform on both Android and iOS devices. And also we wanted to mimic the kind of environment we'd find ourselves in when faced with a commercial project. So when it came to styling, we actually decided to work off a design specification built in the Adobe suite. This meant that instead of simply being happy with where things had been placed in the app and leaving them there effectively, we would have to utilize our own styling skills to ensure the app would have looked just as the client might have intended. Not only does this help to develop our styling skills, but also allows for some basic prototyping in the app's design in the early stages, which gave us a really good opportunity to build on the user experience and the user interface. Now over to Richard for some back-end tech.
In terms of back-end technology, we have a Node.js app which runs an Express server and communicates with a PostgreSQL database using Connect.js. All of this is hosted on Heroku. We're also using AWS S3 to store any images that have been uploaded by the user. Our app serves API endpoints which the front-end uses to perform CRUD operations on the database. We chose SQL because we felt that it was most appropriate for our application. Our data is well structured and relies on the use of quick queries to pull data in efficiently. Our back-end technology choices reflect the fact that we were trying to strike a balance between learning something new, but also using technologies that the team were familiar with as a whole. We realised that our app is fairly front-end heavy, and so we prioritised our time accordingly.
Though we were happy that our choice of tech would be suitable for our app, we did run into some difficulties. When it came to measuring our plants, bigger plants, of about 30 centimetres or more, were less accurate. The accuracy can be thrown off if the photo is not taken from a 90-degree angle, as the difference between the 3D plane in real life and 2D plane on the photo can throw off the perspective. However, we were happy with our simple solution of measuring using a scale, as this gave us the same degree of accuracy to augmented reality, if the plant was not taller than about 30 centimetres or more. During development, the different development environments amongst our group made it trickier to view our app together. 2 of our members were using iOS, the others Linux. This meant we could not use the same development environments, which included the emulators which showed us how our app works on an actual phone. For iOS users, they could emulate a virtual phone on their computers, whereas Linux users had to run the app on our actual Android phones, as virtual emulators for Linux took up too much memory on our laptops. This meant that, during pair programming, we could not view our app on Android together. However, there was an advantage that it meant we could see how our app looked on both iOS and Android, which helped us a lot when it came to styling our app. We also gained a better understanding of the challenges of developing an app for both iOS and Android, and how developing an app for one or the other might differ. The most notable difficulty we had when using React Native was understanding how different the React Native navigation was compared to any routing we had previously used with other tech. As we have about 15 different screens on our app, it took us longer than expected to feel comfortable with how routing works on a mobile app. However, we were pleased we were ultimately able to set up navigation in a way that gives a good flow to the user experience.
Learning to work in an agile environment was always going to be a new challenge. Having to do this remotely in a group setting while building an app from start to finish came with its own unique set of learnings. We scheduled regular stand-ups throughout the day to ensure we were all on the same page about the direction and progress of the app. Pair programming was utilized throughout the app build to ensure everyone was learning new skills and helping each other overcome obstacles. Pairing was switched up throughout the app's build to keep everyone integrated. Overall, we were really happy with how we worked collectively on this project, especially given none of us have met in person. The fact that we were able to build a fully functioning app in 2 weeks gives testament to our skills as an effective team.
We're very excited about the potential of our app, and we have some ideas for further improvements. Specifically, we'd like to add to our infographics page to allow the user to track other aspects of their plant which might affect its growth, for example, watering frequency or soil type. Other potential improvements also include user authentication and the addition of an overlay on the camera viewfinder, allowing the user to take better images and improving the accuracy of measurements taken. Overall, we're very happy with what we have achieved as a team. Thank you for watching our presentation.
Hi, good afternoon. We are Chicken Tinder, a team consisting of Lee, Talisa, Laura, Christoph and Jordan. Our app was aimed at a group of friends who can't decide on where to go for any social event, for dinner. That age-old argument, I fancy there, I ate there last week. We look to solve that. We look to take the restaurant repercussions out of restaurant roulette by making it more of a restaurant referendum. An app with a slick user interface and an algorithm to match to return a winner. With all that said, let's hand over to Talisa to show you Swipe. match, eat.
Thanks, Lee. I will be taking you through the app. First, I will sign up using Firebase authentication with a dummy account. But for the purposes of the walkthrough, I will log out again and then sign into an existing account to create the event that we're going to work with. From my homepage, I can now create an event for the team, and here I will be able to give it a name. We'll call it Chicken Tinder Launch Party, and then I'll be able to set my location, either using current location or using an autocomplete feature that makes use of Google Places library. Then I will invite my friends by selecting the checkboxes next to their name on the friends list. By selecting it once, I add them. By selecting it again, I will remove them from it. Once they've all been added, I can create the event, and Take Me to Event will then take me to the list of 10 restaurants generated by the app. My friends and I can then start voting, and the voting works that swiping right indicates a yes and swiping left indicates a no. Once everybody has finished swiping, as is demoed now, using a mix of Android and iOS devices, we will be able to get a match, our winning restaurant. So the restaurant that was most favoured by everybody. Going into this to see the winner, you get the winning restaurant card, which shows you everything you need to know about the restaurant, giving you a description, the cuisine options, the type of cuisine, as well as their phone number, location, and a quick link to their website so you can book directly. I will now be handing off to Laura to talk about the front-end tech stack. Thanks.
Hi. As a team, we explored different options for building the front end of our app, such as React Native and Flutter, but we ultimately decided to go with React. We were all familiar with React from the Northcoders course and thought that the familiarity would be beneficial considering our short time frame for creating this app. Even though we were familiar with React, we challenged ourselves with other new technologies. On our back end, we used GraphQL. This will be discussed further shortly, but we needed a way to interact with this on the front end. This is where Apollo Client Provider came in. This facilitates the interactions with GraphQL and works seamlessly in React. Apollo Client is designed for modern React, and this enabled us to use up-to-date features such as React hooks and therefore the Apollo React hooks. Hooks were not a part of the curriculum at Northcoders, and this added an extra level of technical ability, but another learning opportunity as well. Our login and sign-up feature uses Firebase for authentication. Firebase is user-friendly and provides security straight out of the box. It also integrates nicely with React. Firebase generates its own unique ID, a UID, which provides a way for us to track logged-in users, but this came with its own issues, which will be discussed later. When creating an event in the app, location is an important parameter. A user has a couple of options to provide a location. We have an autocomplete feature that utilizes the Google Places library, so a user can pick a very specific location. This will allow them to plan for events that may be further away from home. For those events that might be staying closer to home, there is the ability to use their own location, which uses the HTML geolocation API, alongside the Google Maps reverse geocoding ability so that it will output a readable address to the user. And it wouldn't be a Tinder-like app without swiping. For this, we used a very simple NPM package called React Tinder Card, which provided us with basic swiping actions. We were able to build on this to integrate it into our voting functionality by sending our votes to the back end depending on swipe direction. Finally, we use Material UI for styling our app. This was new to everyone on the team, but we all agreed that it was very user-friendly, easy to pick up, and the documentation was excellent. It can also work alongside existing CSS. It provided a great way to have multiple users apply styling to produce an app with a uniform and clean looking design. I'll now hand you over to Christoph, who will talk about the back end.
Thanks for that. So on the back end, we definitely wanted to engage with some new technologies during this project to show that we're able to pick up new concepts and also use them straight away for building. One of them was around storage, so we wanted to explore non-relational databases. We settled on MongoDB, and we used MongoDB Atlas, which is their cloud-based storage service. It's very easy to administer and links well to the Node Express server that ultimately runs our backend app. Between storage and the server, we have Mongoose, a library that uses schemas to define data types, and it also is responsible for the CRUD operations, reading, writing, updating records. The main chunk of our learning was around GraphQL. Jordan's going to go into that in a bit more detail, but the power of GraphQL is really to build up more flexible queries and mutations, so have access to data from the back end, only data that is required and not everything as a dump. Similarly, when we're updating, we can have a bit more flexibility. It also comes with a testing tool, Graphical, which has been really powerful, and I think the whole team have used it extensively, which is kind of self-documenting, and it allows team members to kind of see what currently is available on the API and how to interact with it. For further testing, we use Jest, which we already know, and Axios as well to get information from our TripAdvisor API for our restaurant data. So over to Jordan now to talk a bit more about GraphQL and some of its considerations.
Thanks, Christoph. So I'll talk about some of the challenges the team faced during the project. And our biggest initial challenge was actually learning GraphQL and getting to grips with how the schemas are built and how data is queried and mutated in GraphQL. And this is quite different to like the normal get and post requests you make with a RESTful API, which is what we learned during the course. So it took us a bit of learning to get to grips with that. And we also found that error handling on the back end is different with GraphQL, and as there's only one endpoint. And although GraphQL has some inbuilt error handling, it's not as easy to customize or control as what we found with a REST API. The other main challenge was integrating Firebase with our MongoDB database. Both Firebase and MongoDB automatically generate unique IDs, and we needed to link these throughout the app. We didn't foresee this being an issue during the spiking phase, and then we were then too far along in the project to change our database to say Firestore, which would have provided better integration, but thankfully we found a workaround in the end. The other other main challenge was the TripAdvisor API we were using, which is where we're getting the restaurant data from for the app. And this was a freemium version of the API, which had a limit on the number of API calls you could make on the account. I think it was 500, which we burned through pretty quick in the first week. And we also found some of the data coming back was inconsistent, didn't have any description or photos of the restaurant, and so we had to get around this by applying some filtering at the back end to remove those. And I'll lastly say, although we were the only Northcoders cohort which has been fully remote throughout the whole boot camp, so we were kind of used to remote working and the remote working environment, it did still have its kind of issues and challenges, more on the technical side, to do with data speeds and connection stuff. And we also had to deal with the odd barking dog and gnawing parrot and inquisitive child during our stand-ups and pair programming. So there were challenges there, but overall we were kind of used to it, and it worked pretty well. And which moves nicely onto kind of how we worked as a team. So I'll just kind of briefly explain that. So we used Agile Practices like daily stand-ups, and we had a virtual Kanban board using Trello. For the stand-ups we used Discord, and we had our own channel in Discord, and we probably had 2, if 3 stand-ups a day. We did a lot of pair and mod programming using Discord and VS Code live share together. And then we also used Git for version control as well, which worked really well. And in the initial start, like the planning stage of the project, we used Xmind for like flowcharts and mind maps as well. And overall, the team worked really well together. So now I'll pass you on to Lee, who's going to just finish up and give a roundup.
Thanks, Jordan. We are very proud of what we have achieved and created in just 2 weeks. A team working fully remotely who have never met each other before have come together as a great unit and with a great example for remote working in this modern age. We see an abundance of opportunities for this app, greater customization for the user via dietary requirements, price brackets, and monetization for businesses to connect businesses to consumers through tech like Sockets.io to create a live messenger service. Thanks for taking the time to view our app and our presentation. We welcome any questions in the live chat below. All that remains is for us to finally meet as a group, if only we can ever decide on where to eat.
Hi, I'm Catherine and welcome to Team F4N's project. F4N stands for Favour for a Neighbour, which is our cross-platform mobile app designed to make it easy for neighbours to help each other with specific jobs or household tasks and for skills to be shared across communities. Our app also allows users to raise money for a charity of their choice whenever they help out someone in their area. F4N was inspired by an increased sense of community spirit that a lot of us have felt during the recent months in lockdown. For example, a number of us have joined neighbourhood WhatsApp groups for the first time and have got to know our neighbours much better. We've also seen an increase in neighbours helping each other out by, for example, doing shopping for those that are isolating. At the same time, lockdown has also highlighted that a number of people live in quite serious isolation, so we thought it would be great to design an app that can build on this increased sense of community and help improve the lives of people who could sometimes do with an extra helping hand from someone nearby. We began our project by a simple brainstorming session where we talked about what features we would like to see on the app, and we used Xmind to build a mind map. We considered the perspectives of both the user posting a job and of those users volunteering to help, and we ensured we built out detailed user stories. We also established a clear, minimum viable product to work towards and ensured that we focused on hitting that MVP in the initial few days of our project. I will now introduce Seb, who will demonstrate Favour for a Neighbour.
Thanks, Catherine. Hi, I'm Seb. I'm going to walk us through the app. Firstly, what we want to do is sign in. Once you've signed in, uploaded an image. You don't have to upload an image at this point. If you don't, you'll just be left with an avatar. We'll then go to post a new help request. Once we've filled out the help request form, location where we are and the pledge amount, and uploaded an image, we will then go to review the help request and then change the image if need be. I didn't like the image that I used for this demo, so I changed that. Once you're happy with the job, you can then log out and wait for user 2 to come and help.
I'll now demonstrate our app from the viewpoint of a user wishing to offer help. I'm able to view a list of requests and filter them down to requests in my local area. I can then select a job that looks right for me and get a more detailed view of what is required. Since I think this job is right for me, I can leave a comment. If needed, I could also ask further questions about the job. I'll then click the Offer Help button to generate a notification to the user who requested help, letting them know I'm happy to be of service.
Now James has offered to help, I will log in and view my notifications. As you can see, there's a notification showing James has offered to help. I will now go to the help request and approve which helper I want. Once the helper has been approved and the job has been completed, I can mark the job as done, and the job is then removed from the list and archived in the database. Thank you all for watching. I will now go on to talk about the front-end tech choices. For our front-end tech stack, we use React Native Elements, Expo, and Axios. As a group, we naturally gravitated towards creating a mobile app. React Native seemed like the perfect choice as it built upon pre-existing knowledge of React. We found React Native fun, but it was a challenge to get our head around at first. Another thing we was keen to do with this project was to learn React hooks in place of class components. We used Expo to handle a lot of our issues around cross-compatibility with emulators, as our team had a mix of Mac and Linux users. It also provided a quick method to get our project up and running. React Native Elements is a UI toolkit that gave us access to pre-built components. This allowed us to swiftly implement new functionality pretty much straight out the box. Finally, we used Axios for all our API requests. With wide support and great documentation, this was just an easy choice. Moving on to James for the backend tech stack.
Our backend tech stack consists of Express, Postgres, Next.js, and Firebase. We used Express to create our REST APIs, as we wanted to quickly have endpoints up and running to avoid any impediment for the front-end team. As we were familiar with Express from the course, this allowed us to rapidly deploy front-end and make changes quickly as and when they were needed. Building on our strength and love of Express proved invaluable to keep the back-end nimble. For data storage, we used Postgres, as our data was highly relational. This allowed for data normalization, removing redundant data and improving data integrity. As we were most familiar with JavaScript, we decided to use Next.js to construct our database queries. This had the added bonus of having integrated migration and seeded functionality. This was extremely useful, as it allowed us to reseed our database each morning, removing the test data we added during development the day before. We used Firebase, Google's mobile web application platform, for authentication and image storage. Firebase provides an easy-to-use interface for account management and React APIs for simple integration into our front end. We were then able to use Firebase Admin SDK to authenticate requests to Express. Firebase Cloud Storage was used to store our job pictures and user avatars. We hosted our backend on Heroku, as it allowed for quick deployments using our source control software Git. I now pass you over to Rob.
Aside from one or two small headaches, such as the morning where we accidentally Git merged our development branches in the wrong direction, by far our greatest challenge was getting to grips with two new technologies, React Native and Firebase. Rather than all four of the team focusing on both, we made the decision to split our capacity to make the best use of our combined development time. Once the essential database structure was operational, one person from the back-end and one from the front-end sub-teams switched their attention to Firebase. This allowed for a team member with experience of React Native to provide input into the implementation of Firebase and avoid any conflicting code. Building on the team's existing knowledge of React meant that understanding of the documentation available for React Native was, on the whole, straightforward, and any difficulties were easily overcome. Whilst there is a wide array of component libraries available for React Native, such as for adding drop-down menus and inserting images, etc., we encountered difficulties when it came to styling them to fit our chosen theme. Where possible, we stuck to using React Native core components, as these proved easier to integrate. Alongside a great team spirit, we knew that good communication would be essential, and remote working could have slowed us down. The text and voice chat functionality provided by Discord proved invaluable and was used continuously over the 2 weeks. We held morning stand-ups for everyone to discuss their progress and highlight any concerns, and throughout we made use of the web-based capabilities of Trello to visualize and manage our workflows, ensuring that critical aspects of the project were completed on time. The live share extension for VS Code made it quick and painless to work in pairs, although the live server extension proved too much of a strain on the internet connection for one of us, resulting in an urgent visit from the nearest BT engineer. Finally, we'd like to mention one or two features we'd look to include if the project were to be taken forward.
So we're all really pleased with our app, and we've worked well as a team over the past few weeks to build a great product. But we're not finished yet, and we've got lots of other ideas for future features that we'd like to add to make the app even better. For example, we've discussed that it would be great to add some payment integration into the app to allow for the charitable payment to be made direct within the app rather than having to go via an external Just Giving link. We would also like to add a chat feature to allow users to message each other within the app privately and securely. We've also discussed adding a feature to allow a job to be shared on Facebook. And one more potential change would be to consolidate our backend into Firebase and take advantage of Firebase's backend offering. This would allow us to simplify our backend and give us a single point of administration. So there's lots more exciting features we would like to add to Favour for a Neighbour. In the meantime, we hope you've enjoyed learning about our app and enjoyed watching the presentation. We welcome any questions. Thanks.
Good afternoon, everyone. My name is Petru, and today Alex, Ethan, Tim, and I will be presenting our new and exciting app called langsnap. The aim of the app is to make the task of learning a new language easy, fun, and interactive. It's an all-in-one tool which includes a translator, the ability to save the words which you translate, a quiz, and provides details on how you're performing every day. The main feature of our app is the ability to identify objects within the user's environment quickly by using the TensorFlow.js machine learning framework and the pre-trained MobileNet version 2 model. This introduces the user to words which they commonly use and helps them remember the words in the new language by creating a visual link between the object itself and the word in the new language. In contrast with some of the other apps available on the market today, you don't have to sign up or pay for it in order to begin using it. So, let's get started. As we open the app, we are immediately taken to the main page, where the video camera captures objects which you film and displays their English name below the screen. Once you're happy with the word, simply select the language and press the Translate button to get a translation. The detection of the name of the objects is made possible by the TensorFlow.js machine learning framework. To unlock more features, you must complete a quick sign-up form using your name, email, and the chosen password. But for the purposes of this demo, we will log in as an existing user. The authentication process is of course handled by Firebase in the back end. As a registered user, once you translate the name of an object, you can then request a list of verbs, adverbs, and adjectives, each with an accompanying translation, made available from the Associated Words API. This feature is meant to help the user form sentences. And every time a registered user clicks on the Translate button, the English word and its translated counterpart are saved in the words list section of the app. A user must translate words before they appear in the words list. The Account section of the app provides a graph which details the amount of words in each language that a user has learned. Another key feature of our application is the multiple choice quiz. To begin, select a language in which you want to take the quiz and simply click on the correct answer. It is worth noting that the user can only access this feature once they have translated more than 2 words in a given language, so that the app can generate a random list of words in the language that you select. If you want to take the quiz in a different language, and you have translated enough words in the language, click on the button below and select a different language. The more words you have, the longer it will take a user to get through the quiz. Once you are done, you can safely log out. Next, my colleague Ethan will describe the technologies used on the front end in more detail.
Hi, I'm Ethan, and I'm going to be talking you through the front end of our application. For the front end tech stack, we use React to build our app, TensorFlow for machine learning, and vanilla CSS for styling. This was a mix of new technology and technology which we had learned on the course which we wanted to put into best practice. Because of this, we had an idea of what we needed to do and we were capable of building our application with these skills previously learned. One of the things that was new to us was TensorFlow. TensorFlow is a machine learning framework in which we use to deploy the MobileNet version 2 model to detect objects in real time. In the early stages, as a team, we all spiked out this technology in order to get to grips with it so we can start on our application as soon as possible, as without this feature, our app would simply not work. After spiking it, we came together in a stand-up and collectively shared our findings, and from there built a simple camera implemented inside the browser. We wanted our app to be browser-based as this would cater for all devices. We found that the barrier for using TensorFlow was very low and the documentation is very easy to follow. For the user interface, we use React. React was used to display the predictions in order to detect what TensorFlow was picking up. Using this meant there were lots of re-renders every time a new object was detected. Therefore, we wanted to only re-render a small part of the page, but it needed to change regularly. We had a clear vision of how we wanted the app to look. We initially considered styling with frameworks like Bootstrap and libraries such as Tachyons, but found that it would be just as easy to use vanilla CSS. Finally, as a test suite, we used Jest to use on any utils functions throughout the app by using TDD.
Hi, I'm Tim. I'm going to be talking through the back end of our project and the technologies that we've used. At the outset, we decided we wanted to leverage the back end of our project to help us build a robust and secure application. To achieve this, we've used a number of technologies. The first of these was Express. We chose Express as it provides an unopinionated server framework that allows for the integration of third-party technologies. We integrated Firebase auth middleware to ensure that the safe storage of passwords are handled by a third-party system that is robust and tested. And furthermore, it gave the advantage of having a protected API route to handle sensitive communications from the front of the application to the relevant services. With the authorization middleware installed, we chose to partner our application with the Firebase real-time database. Our application has very little relational data, and as the functionality of our application must be built on individual slices, we could leverage the flexibility of a non-relational database to achieve continuous service as we progress through the build. As there are a number of third-party APIs integrated into our application, with the exception of TensorFlow, we chose to fetch that data from our backend. Doing this ensured that we could control the errors and that the front end of our application had a defined set of responses for each API call. TensorFlow can be deployed in a number of ways. The two we explored in detail were installing as an npm package or requiring in as a CDN. During our initial spike, we had already migrated from MobileNet v1 to v2, and rather than update dependencies, we used a CDN file within our application to make the API calls to TensorFlow. This ensures that we've always got the latest version of TensorFlow running in our application. Naturally, we had a large number of API calls to make, and to ensure that we could leverage the power of those third-party applications, we employed Axios. Axios gave us the ability to write multiple queries and therefore reduce the number of models in our backend. This was to ensure our code was as dry as possible. We used Mocha and Chai to ensure that each route in our application is tested, as Mocha and Chai allow for specific assertion tests, and the before and after hooks allow for clean tests with proper setup and teardown. Finally, we hosted early with Heroku. This was to ensure that development work for the front end of the application could continue at pace, and we could continuously deploy after each new feature following robust testing. Okay, so on to technical challenges. Naturally, the largest technical challenge we faced on this project was TensorFlow and integrating that with our application. TensorFlow was originally designed for a static web page, and we need to make it work with the virtual DOM for a React application. This meant ensuring that the canvas and video feed was kept alive even when the React virtual DOM re-rendered. As TensorFlow makes an API call, we had to control the number of calls made and the accuracy of the result returned. To achieve this, we had to create a function that could control the frame rate and the API calls, therefore controlling the rate of prediction. With this function, we could dramatically increase the accuracy of the information presented to the user. And furthermore, we wanted our application to work on low-powered devices and to be accessible to anyone with a browser. As a result, it was imperative that we reduce the load on internal computing resources and data. Finally, we used some random logic to operate our game, and this created a number of issues. The greatest of these was how to ensure that the user was not presented with the same game twice. If we had to do the project again, we would look to use an alternative logic to ensure that the game is played in a specific pattern. Thank you.
Hi, I'm Alex, and I'll be talking about our use of Agile Practices and the possibilities of future development for our app langsnap. We knew that from the outset we would be working entirely remotely for this project. Because of this, we knew that communication and thorough preparation would be key to achieving the minimal viable product. As the project would be front-end heavy, we decided that rather than splitting the project into front-end and back-end and dividing our team as such, we would split the project into multiple slices. This would mean at the end of each slice we would have a functioning product, and as a group gave us the opportunity to review our progress and decide if any changes should be made. It also gave us the chance to be flexible with assigning tasks to each member and gave us all a deeper understanding of our app. To stay organised, we made a Kanban board for each slice with Trello and designated tasks to pairs. We held 3 stand-ups a day to ensure continued communication within the group and to maximise the time and resources we had by keeping everyone on track at all times. When designing and wireframing the app, we used Figma, Xmind, Pinterest and Google Docs, which can be edited online and meant we could all easily contribute. We used Zoom and VS Code's live share to work together, which other than occasional internet issues worked well and mostly meant the remote workflow was seamless and unproblematic. When it came to using GitHub, we varied our practices depending on what was required for that specific slice. When approaching a project together, we used truncated development. But when working apart on features such as the quiz, we found branching using the Git flow style worked better. It was important for us to get the back end hosted early, as we knew we'd need to make use of it when building the front end. We also knew that spiking out the object recognition side of the app would be one of our biggest obstacles, so we worked on those elements simultaneously. When it came to building our front end, we had a robust server and a good understanding of the technology we would be implementing. We also hosted the app pretty early on in the development stage. This meant we could continuously deploy the project to test it on our mobile devices and get feedback from our peers, which we used to seek out bugs and develop the app's features. It was genuinely a pleasure to work together in this team. The fact that we got on so well meant that staying honest and constructively critical of each other's code was not a problem. We often mixed up the teams during pair programming, and the work was always fun and productive. I'd like to say thank you to everyone for watching, from myself, Ethan, Petru and Tim. We had a really good time on this project, and we hope you have fun with langsnap.
And there you have it. Thank you to all our graduates for presenting today. All of your hard work and perseverance over the past 12 weeks has accumulated to 4 really impressive apps. Thank you to everyone who has supported them from home and afar, and I hope you'll join me in one final emoji round of applause for our teams. Thank you for watching, have a great weekend, and look after one another.